Okay, let's start. Hello, everyone. Welcome to the 2021 Computer Science Honors and Minor Thesis Information Session. My name is Xiaodong. I'm the coordinator of the honors program and the minor thesis course. So this is the agenda for the information session today. First of all, I will take 10 minutes to briefly introduce the program and the course, as well as explain why you should do it and how you should start. Next, our 6 computer science research group leaders will give short presentation about their research groups and briefly introduce their representative research projects conducted in the groups. Next, our 2 past honors graduates will share their successful stories. Finally, we will have a short Q&A session, and I will conclude the session today. Let me start with a brief introduction of the honors program. So for Bachelor of Science Computer Science honors, this is a 1-year full-time research degree in which you are required to complete 3 advanced elective computer science courses, a research method course, and 4 science honors courses. For the research method course, the expected outcome is to complete a research proposal under an RMIT computer science academic staff member's supervision. For the 4 science honors courses, students are required to complete a research project and a research thesis under an RMIT computer science academic staff member's supervision. The project and the thesis should include identification of a research task or a research problem, a survey and analysis of the literature related to this research task or problem, an implemented solution to the task or problem, as well as critical analysis of the solution. For example, analyzing its advantages and disadvantages, mostly in terms of scientific experiments. Finally, a written thesis, including all the aforementioned components. For the minor thesis course, which is a research-based postgraduate course worth 36 credits, it has the exactly same requirement as the 4 science honors courses in the honors program. Let me explain why you should enroll the honors program or the minor thesis course. First of all, many students may think I only need to do minors or honors because I want to apply for a PhD program after graduation. This is not 100% correct, because with this program, you will have opportunities to work in a cutting-edge research field in which you will learn the frontier computer technologies, develop your creative thinking, and have opportunities to create innovative IT solutions. You can never meet such opportunities when you are doing normal courses. Eventually, you will become an expert in a subject matter. This will definitely enhance your career prospect. The second reason is RMIT computer science research has a very high global reputation. For example, it was ranked among the top 100 universities in the world in the 2021 US News Computer Science Ranking. The research in our 3 computer science disciplines, namely AI, data science, and distributed systems, were all rated above the world standard by Australian government recently. Imagine that you will undertake original and frontier research under the supervision of the internationally recognized researchers. How amazing it will be. the last reason is definitely the primary goal of this program or this course is to provide students in sufficient research training to proceed immediately to PhD studies after graduation. For example, many students even have the opportunities to publish their honors or minor thesis work in reputational international conferences or journals before they start their PhD program. So here I just want to add a little bit more flavor to inspire you to enroll in this program or the course. So this is the minimum entry requirement for PhD program. For undergraduate students, you have to complete an honors degree with weighted average mark of 70% or above. For master by coursework student, you have to complete a minor thesis course, and the weighted average mark of your master's program must be over 70%. Actually, most of the Australian universities follow the exactly same standard. But keep in mind, this is the minimum requirement for PhD entry. If you are keen to apply for a PhD scholarship from RMIT, for honors student, you have to get an H1 honors, which means your honors program's weighted average marks should be at least 80%. For a postgraduate student, your master program should achieve an average GPA of 3.3 or above. To be eligible for the honors program or for the honors program, you have to get a bachelor's degree in a computer science or IT related major with an average GPA of 3.0 or above. For minor thesis project, actually this course is already included in the study plans of almost all our master programs in RMIT Computer Science, like Master of Computer Science, Master of IT, Master of Data Science, Master of AI. You have to complete a research method, and your average GPA in the preceding semesters must be over 3.0. So what happens after this session? I will share a SharePoint link in the chat room. In the SharePoint, you can find all the presentation slides and also the up-to-date computer science honors and minor thesis projects, and also the link to access the video recording of this information session, which will be published in YouTube. So just give you a brief look of the the honors and the minor thesis projects. So here shows whether or not this project is published in 2021, the primary supervisor, his or her contact details, the relevant research area, the required research skills, and also the project description. If you are interested in any of the project, I suggest you directly contact the project supervisor via his or her email. So here are the useful links for the program and also the course. And if you have any question regarding the program or the course, you may leave your question in the chat room and add me in front of your question. Next, I would like to welcome our group leaders to briefly introduce their project groups and the ongoing projects. Okay, so first of all, let's welcome Professor Margaret Hamilton from from the research group of computer science education research to introduce the project conducted in their research group.
Thanks, hi, and hello everyone. Our group is a bit smaller. A few people took packages last year, but all of us have supervised master's students, honours students, and PhD students. And we welcome you with any interesting projects that you may have to contribute as well. We're happy to discuss, work out some interesting research questions, and get some good background reading for you to start on. Next slide, please. Hi. So some of our projects in the past have included looking at learning analytics. In computer science, we're always interested in measuring things, and one of the things that we measure in education is how people learn. And we like to look at the Bloom's taxonomy for the levels of difficulty of questions. But it's not just questions and exams that we look at and study, it's how people go about answering questions. And in particular, what we're looking for is a discriminated question. So if we could ask this one question of a student and everyone who passed it was a good student and everyone who failed it was not, that would be an interesting discriminated question for us to work on. And we wouldn't have to worry about setting a whole exam. We could just ask that discriminated question. But we're after questions like that that can tell us a little bit more about how people are thinking and what they're understanding. At the moment, we just look on the students' performance as a predictor of how they'll go into the future, but we also aggregate a whole lot of other student performances and can work out then how, if you're passing or getting a certain mark at a certain stage in the semester, how you'll go at the end of the semester. So we're looking at using these analytics as predictors. Next slide, please. Hi. Another interesting project is looking at visualizing of code. And one of the ways that we can do this is through the virtual robot. Some people learn better through visualization and understanding problems, maybe the Towers of Hanoi or various other different game projects. You can look at better how the instructions work on the code. And we can also look at analysing some of the errors that people make, particularly in loops and in organising nested loops and things like that. It's more for introductory programming, novice programmers. And so far it's been only in Java, but it will move towards Python and there will be further expansion of this project. Next slide, please. Hi. Another interesting area in computer science education research is employability. So what kinds of jobs do people get at the end of their degree? How can we train them better? What kind of skills should we be equipping them for to be more creative, to become more entrepreneurial, more innovative in their jobs? There's a lot of work that at the moment that's going into looking at what we in the past maybe called socio-cultural factors, their economics, whether or not their family have become entrepreneurs. All these kinds of questions have a bearing on the kind of student who might set up their own business. But so far, there's not a lot known about Australian entrepreneurs, much more about the American ones, like obviously Bill Gates and Jeff Bezos and people like that. But there are several successful Australian entrepreneurs, including past students from RMIT. Next slide, please. Hi. So basically, we're interested in any research into learning and teaching that can help us with the students, help us understand how better to assess them. We have tools that can gather data. We can aggregate the data and give us a better understanding of some of the problems and issues that people have with various different things. We're looking at helping with diagrams and giving feedback on sequence diagrams, UML diagrams. When we say intelligent tutoring systems, that means we're looking to personalise them and give students practice on certain kinds of questions. And also we're looking more at assessing teamwork and collaboration, because that's the way of the future and the way of a lot more jobs people put into teams. And how do they help each other and work better in these teams? How do we communicate better? quite a good rubrics for measuring learning. Another project down here we've also mentioned is what makes a good and sustainable e-learning system. We've changed learning systems several times at RMIT, and how sustainable is IT into the future. All interesting projects for honours or small minor projects, which can also move into PhDs in the future. So that's all from me now. Thanks, Hai.
Thank you, Margaret. So next, let's welcome our second speaker, Professor Zahir Tari from the research group of computer cyberspace and security, to present the projects conducted in his research group. Yeah,
thank you. Hi. Well, I'm standing here. I'm a little bit have back problem. Sorry about that. Maybe it's the lockdown. It's happening. No, just first step. Yeah, first slide. So my name is Zahir, and I'm from the School of Computing Technology. But at the same time, I'm also the research director of the Cybersecurity Center. And basically, the center is across different schools. So we look at security from computational perspective, the algorithmic perspective, but also from mathematics with people from mathematics. So the theoretical part, but also from engineering as well, the hardware security and so on. So I won't talk about this project, of course, and all of that, but we are, our team, not yes, the discipline, I don't know why you're,
okay.
The discipline, just take it easy. The discipline is definitely has critical expertise in cybersecurity, but also discipline is not just on security. The discipline is on cloud, and a lot of you probably have done the subject of high. It's about the infrastructure to deliver large computations, like large data analytics. It's a very important cloud infrastructure and how to manage the infrastructure, right? From a performance, from scalability perspective, and also from a system perspective, which is really how to get the performance and so on. So I will probably briefly talk about the discipline and less about the project, what are the expertise, and I'll go quickly through the projects. Can you go through the next slide? Thanks, hi. Next slide. Yes. Okay. Oh, what's happening? Can you come back? Okay. I don't know with all these colors, but you have some of the members here are also included, and Margaret spoke about them already. The people who are doing software engineering, so they are part of the discipline. So we have all the people on the right-hand side, the last column, which are the postdoc, who are really our active researchers, and the other ones are all the members of the disciplines. And when you look at down there, Iqbal is the associate dean, is the person managing the discipline. So we have the discipline is around 16 people and 4 postdocs. So we have a lot of critical mass in terms of research, and we are doing a lot of research from fundamental to the application and so on. So we're looking at the research part and the research projects, both from the theoretical and the application part. And you can see the red people here, the red team are the security team, the people who have really cybersecurity. The blue team is the people who are from system, cloud, and so on. And the blue and red, like Ibrahim, he has both expertise in security and so and systems. And quickly about the discipline, ERA ranking. No, we haven't finished. Quickly, I will go quickly. High. So we are ranked 4. I mean, internationally speaking, we are quite well known, and we are involved in 2 centers. The Cybersecurity Center I spoke before, and we're also in the industry hub. We are looking at the cyber aspects in the space industry, from the cybersecurity and so on. I'm one of the program lead there as well, with the people from aerospace and so on. So these are the data, the successes that we have. We have a lot of links with industry. We work a lot with industries, taking the theory into practice. And also we have some product as well. We are not just coming up with the new models, but we also make them also as product. Can you go to the next stage? Hi, next. So these are the different areas, right? These are our strengths. We are strong in cloud, cybersecurity, distributed computing, and blockchain, right? I use the same color like I used before. So in cloud computing, we do a lot in research in resource management, how to scale up, how to get a better performance, and working a lot on privacy as well, how to make sure that the data that is in the cloud is secure.
You have in 1 minute.
Oh, sugar. Okay. So a lot of data that we have are in the cloud, are in data centers. I have to make sure they are not attacked. There are a lot of cyber attacks on the cloud that are specific to the cloud that need specific, basically specific solutions. So these are what we are doing in cloud. As I said before, we are working a lot on cybersecurity, and we have a lot of people working on privacy, people working on watermarking, and working also on critical infrastructure, like a power plant, electrical, because the security in these applications, they require they have specific requirements, like the real time. So when you detect an attack in a critical system, you have to do it in real time aspect. You cannot just detect it 1 hour, 2 hours later on, otherwise the power station will blown up, right? So we are working on distributed system aspects as well, and blockchain. Blockchain is, we have quite a strong group on blockchain, which involves quite a few people. That if you're interested, I'm happy to introduce you. What I will do, because I don't have a lot of time, I will go quickly through the projects, okay? Does it make sense, hi or not? I will stop here. Hello? Hi? Hi? Do you want to go through the projects?
I would suggest let's stop here.
Just go to the next one, and I will just give an example.
Okay.
There are a few. I didn't want to talk too much about the projects because there are several projects and there are several slides. So, for example, Shabnam is one of our young one is working on searchable encryption. She works on encryption in cryptography and how to search, how to allow search of keyword in encrypted data, right? So what you need to do, look at the project and try to talk to her and try to see how you can get involved with her. She has a lot of experience in research and she has published a lot. So please feel free to talk to her. And there are other projects. The next one will be from Meng, right? Meng works on IoT. IoT is used a lot in smart cities and so on, is how to make sure the data is protected in IoT environment, right? So she works on automatic security modeling and intrusion detection. This means how to find an anomaly when there is an attack, how to detect it by looking at the patterns within the network, right? It's an abnormal behavior. So there are a lot of people who have been working in this area, but I think the challenge is how to do it in real time as well, right? So the next one will be from. Okay. No, I will stop here. There are several.
Okay, let's stop here.
Okay,
Thank
from
you.
high.
Thank you very much.
Okay.
Thank you.
Okay.
So next, I will let Xiaodong to share his screen from his computer. He's going to be presenting the research project conducted in evolutionary competition and machine learning.
Hello, everyone. I hope you can see me and hear me. So
yes,
my name is Xiaodong Li. So we have a research group on evolution, computation, and machine learning since 2002, so quite a long time now. Yeah. Basically, the group consists of staff member and students interested in nature-inspired computational model and algorithm, especially this kind of evolution computation model and the machine learning. So like a neural network. The evolution computation really is a biologically inspired computational model like Darwinian theory of evolution, right? So you, instead of following more traditional mathematical modeling kind of approach here, you look at how you actually evolve candidate solution, just like in nature. So you can evolve them over time in some ways and picking the fitter ones. So in the end, you get some better and more optimal solution. Just a really, very simple analogy, yeah. And we work with people in engineering and mathematics and solving real-world problems. So it is very interdisciplinary group and done research with industry partner. We have linkage and ARC linkage and ARC discovery grant, and of course now also branching into more broader category like data mining and data analytic, working on like the journey planning. We're going to talk about that later on. But you can see some of the faces here of the member, the staff member. So we have, around 10 member, staff member, 15 PhD students. Some of these staff member, like here, Ming Yi and Hazen and Hong recently joined us in just the last 2 years. So this is a picture of the group, but it's several years now since it was taken. Some people have left, but we have some new people right now, yeah. So here are some of the very high level, just you can see the keyword that we highlighted here, swarm intelligence, kind of again, nature-inspired model following its bird flocking of fish schooling behavior, using that for problem solving. Genetic programming, you can see this is a really idea about applying this evolution idea of evolving a bunch of program. Instead of a human coding it, you evolving them, so automatically kind of generated program. And so that's really a very interesting perspective, right? The machine learning, these days we've got a lot of data. With data, you can apply machine learning method, right, to learn some intelligent behavior like what humans do. Journey planning, we look at this. This is one of the linkage project a few years ago. How actually people pick the best journey according to their preference. So AI in game, I think this is a fabulous expertise. You apply the intelligent agent in a environment, interacting with the environment, and so game theory gets used a lot here. Warehouse storage optimization, Andy Song is expert on that. Working with the industry partner, looking at how you have the best layout so that people do not have to travel too much within the warehouse and pick the right item, most effective and most efficient way. And itinerary recommendation, there's Jeffrey Chan. So you can think about like a tourist traveling, let's say, come to Melbourne. If you want to cover all the different attractions within the limited time frame, let's say 2 days, what would be the best travel route or travel journey for that tourist? So it's have a very practical implication there. People can use it for travel journey recommendation. Engineering shape optimization. Again, this is an engineering application, the airfoil design. So looking at the air wing, the shape of it, how you can maximize the lift and minimize the drag, for example. So that's a lot of engineering idea going into there. We're working with aerospace engineering, RMIT, and house price prediction. This is a project by Victor Chelsky, working with ANZ. I think eventually that was a company that sold it to ANZ. So there was a really successful story. And this is evolutionary art. Again, applied idea about evolution computation to evolve and generate very interesting image with very fascinating pattern, as you can see one of here. So just give you a few very typical projects, not all of them, just too many of them. Here is one project we're currently interested, learning to optimize. Jeffrey Chan lead the project. Basically, we try to combine machine learning with optimization. So not just purely optimization, because of availability of the abundance of data. Then we can learn from the data to construct a model. With that model, we can then do optimization. So you can then alternate between optimization and machine learning in several different iteration. Learn, predict, then come back and then optimize, then predict again. Do it in that fashion. So this is one of the hot area currently. And learning autonomous robotic behavior by Tim Wiley. He's an expert on reinforcement learning. He look at human work collaboratively with robot, not replacing human, but how they can work together in tandem. So reinforcement learning idea gets used because robots have to interact with the environment and adaptively changing, adjusting their behavior. So this is just some of the, just again, high level capture of the few staff members, their interests, like Ming Yi preference reasoning and learning. Hazen is an expert on deep learning. He did his PhD here a few years ago, then went to Silicon Valley, I think, working with Facebook, then came back, joined us as a lecturer. So he's an expert on deep learning, a very successful application of several interesting problems in deep learning. And Hong is an expert on this trustworthy machine learning. She's an expert, in fact, on Bayesian optimization, another very popular optimization technique, especially for surrogate modeling. How you can save computational costs using that kind of modeling is very effective. And Andy Song on machine learning, multi-agent simulation, and textual analysis. Vic Chachelsky is our longtime member, where he been there since, I don't know, the school started, computer science. So he's is expert on genetic programming, computer vision, and robot soccer, this kind of simulation. Myself, my kind of research interest in nature-inspired computation and machine learning, but also kind of my interest evolving over time. In the few years back, maybe I was more in swarming intelligence, evolution computation, but now sort of moving into combining some of this optimization technique with machine learning, and look at how machine learning, in particular machine learning, to enhance traditional optimization technique. So we'll work with people from mathematics and engineering a lot for this sort of approach. Yeah. And in particular, I guess for solving practical problem, combinatorial optimization problem, like the resource scheduling problem in Western Australia, for example. So this is the last slide. I'll finish here. So this is just some of the contact detail. If you're interested in any of this project idea, feel free to contact us. Thank you.
Thank you, Xiaodong. So next, let's welcome Professor Mark Sanderson and Professor Jenny Zhang to present the research project conducted in the group of data science. So Mark, you want to start?
Yeah. Okay, thanks. So it'll be myself and Jenny Zhang will be presenting here. Next slide, please. So the topic, next slide, please. Hi. The topic that we're going to be working on, just go back to the previous one, my apologies. So the topics that we broadly work on are related to analysis and exploitation of data. When you sort of say we're working on data, you might say what kind of data? So the majority of things that we think about are textual data. We think about data related to people, and we think about data related to spatial temporal things. So things to do with location and things to do with time, and sometimes combining those things. So let me take you through some of those more specific topics. Next slide, please. Hi. So we have, particularly around the text and human data, we have interest in human access, search engines, and also recommendation systems. So next slide, please. What I mean by information access, I mean things like search engines, things like Google. We have a number of researchers who work on projects related to how search engines work. And we also have a number of researchers working on recommender systems, which is a bit like what Amazon or Netflix recommends a movie to you or a product to you based on previous behaviors that you've been using as interactions with that system. So it's looking at human behavior to make predictions about what you might want to be able to do next. You might sort of say, next slide, please, that search engines are a bit old. But we've been looking at things like speaking to search engines, having search engines speak their responses back to you. And next slide. And we've also been working with Microsoft on their version of Google Home or Amazon Alexa, which is the Cortana system. And we've been working with them on ways to improve the answers that a search engine provides. So not just finding documents, but finding answers back. Next slide, please. So the other topic that we spend a lot of time doing, we're part of a Centre of Excellence, which is a large Australian research fund, is looking at use of data and use of algorithms and the impact that it has on society. So sometimes that's referred to as fate, fairness, accountability, transparency, and ethics. Next slide, please. And so, in fact, you can just move to the next one. So we've got a project with this Centre of Excellence called the Automated Decision Making in Society, ADMS. This is a $32 million research center that's funded by the Australian government, and a number of people in the data science discipline are part of this project and have projects in that space. So if you're interested in the way that data or algorithms impact on individuals, impact on societal groups, we have projects in that space. Next slide, please. We also have collaboration with the Design and Social Context College at RMIT, who are working on questions of facts. We at RMIT, we actually have the ABC fact check working physically on site at RMIT, and we have a collaboration with them to create this thing called Fact Lab, which is a sort of an experimental space to understand fact checking. So we're working with sociologists on fact checking projects. Next slide, please. So one of the things you'll notice is that we have a lot of focus in these projects that I'm describing on the way that humans interact with systems. Next slide, please. And so we have a number of researchers, which includes me, who think about HCI, human-computer interaction. So if you're interested in projects that perhaps don't involve as much programming, but are perhaps more interested in interacting with people, understanding how people use systems, we have a series of researchers in the discipline who are very interested in supporting you on projects related to that. Next slide, please. So, for example, just some example of some of the projects that are going on in usability, but you'll find when you go searching through that list of projects that there's a wide range of projects. So what I'm going to do is hand over to my colleague, Jenny Zhang, who'll talk about some of the other projects we have.
Thanks, Mark. So Mark has summarized about the society, data, and people. Now I'm going to give you a few highlights of the data analytics projects, data-driven analysis we have done. Next slide, please, Kai. And this is, Mark mentioned just now, text analysis or text to data. So you can call it mining knowledge from text or text mining. So you can see here the range of research we have done there for classification or using natural language processing, using unsupervised learning. So various machine learning techniques and the impacts and the sort of text data we have analyzed, including and the applications, including social media data, textual data, news data, and you can see fake news detection and all these applications. Next slide, please. Hi. And another type of data we worked on is a number of our team members work on spatial temporal data analysis and big data management. And you can see here the applications include trajectory prediction, trajectory search, or data-driven network or route optimization. Next slide, please. And another type of data that several members we have worked on is the sensor data. You can see here there are unmanned automatic vehicles and drones specifically. You collect data from there and try to identify the situation and predict events. And next, please. And management of trajectory data and relational data, as I mentioned just now, for entity resolution, optimization of the trajectory and database management system, specifically from the data management perspective. Next slide, please. Hi. And another type of data that we have experienced, if you're interested in multimedia data analysis, for example, videos or audios, and social media data, and in the context of event detection, or what we talk about event is like news event reported on social networks even before they reach the official the classical news media. So which is if this part of the data that interests you, this is where we have experience. Next, please. And in terms of IoT, in combination with multimedia data analysis, especially for context recognition and user behavior analysis to profile users, and there are a wide range of applications when you have mobile sensors combined with the contextual factors, and you can do a wide range of applications that you can see that we have listed here, identifying user activity, and collect and identify the context of the work environment, from smart cities to smart buildings, and all these a wide range of applications. Next slide, please. Hi. And this is an interesting project that was done by our colleague Flora Salim. And in here, you can see using multiple sensors to recognize human behavior, continued with the what I mentioned just now. Next slide. And here is an interesting stream data analysis project. And when in the age of 5G networks, when you have not only one sensor, but a flood of data streams coming from almost an uncountable number of sensors, then it is the problem of making sense of the data, managing the sensor data, and also the interactions so that you can identify the context and the correlations among the different data sources. So an interesting project. Next, please, Zahir. Okay, and another application that we look into the health-related data, so including the text data from clinical notes, or in this case, you can look at the picture. This is the progress notes written by healthcare providers at 8 care homes. So by analyzing this data, we can predict the deterioration of the conditions and predict and provide better health care for the patients and aged residents. And in here, you will apply and real data problems and applying the machine learning and data analytics and trying to explain the predictions to help in the healthcare domain. So with that, I hand over to Mark.
Yeah, and just the last couple of slides. So the team in data science, next slide, please. We're just going to leave this slide up here so you can see who the members of the data science discipline are and their areas of interest. So look out for those faces or those names as individuals. Next slide, please. Hi. Give you a way into understanding these different topics that we're working on. So I talked about data, I talked about text data, spatiotemporal data, and then different applications related to those different forms of data, and then also research related to human behavior. So a wide range of projects there, and hopefully some that interest you. Thanks, Hai.
Thank you, Mark and Jenny. Thank you for your presentation. So next, let's welcome Professor Sebastian to share his slides in the research group of multi-agent systems. Okay.
Yes, can you see that? Can you hear me? Hi?
Yes, yes.
And you can see my slides?
Yes.
Okay, hi everyone. I think your brain must be full by now. So I'm going to try to be short. So I'm Sebastian Sardina. I'm a member of the AI Agent and Planning Group, which is, by the way, a subgroup of the AI Lab, which is together with the group that Xiaodong talked about, right? We all make it the AI Lab, the AI group in the school, but we are too many, so we have two different kind of subgroups inside, right? Now, let me tell you a little bit about the problem, the research theme that we do, right? Which is, if there's one life I want you to take, is this one, right? So what we're interested in the group, this is a big umbrella, is the problem that we usually call it sequential decision making, right? The idea is that there's an agent acting in an environment, right, doing actions. The environment is dynamic, so it's a stochastic process, and the environment will do changes that the agent will sense, and new actions will come, right? So for example, you can think about the Amazon or many warehouses, right, where this is the environment and many things can go wrong there and can happen, and your agents are these robots that move these trolleys, right, around the environment. So the question that we're interested in is what to do next. What are the good actions that the agent should do? Because it is a very complex environment that is changing, and of course you want to maximize or you want to achieve certain goals or maximize some kind of reward. Now, the question that we're dealing is, how do we build this system, right? How do we build this system? And traditionally, there are three main approaches here. One that you're probably very related, you know a lot about it, is you just program it, right? You specify this control by hand. Now we are interested in that, but we want to go beyond object-oriented programming paradigm. And therefore there are a whole area of research internationally, which is called agent-oriented programming languages, which, by the way, Australia itself is a big leader, right? Not just RMIT, but Melbourne in particular, and Australia has contributed significantly to this area. So basically looking at programming languages that go beyond object-oriented for dealing with software that runs on robots or on a complex system, an embedded system, for example. The second one is learning-based approach, right? We just don't program it because probably it's very difficult or we don't know how to do it, but we have experience, we have data that we have collected over time. We want to learn from the experience, right? And one of the areas is reinforcement learning, very popular these days, right? We learn by acting and getting some reward and understanding that how the agent should behave in the future better and better. Another approach would be evolutionary computation, which Xiaodong discussed, right? So basically evolving your system with time, looking at how the system is performing or could perform, right? So here we don't program, we just learn from the experience. The third one is model-based, right? Very similar to what engineers do. So we derive the control automatically. It's kind of automatic programming, which is a holy grail of computer science itself, right? Avoid programming, just learn the program automatically. But we do it from a model. Very much like, engineers use differential equations. We use different kind of models to represent the environment and the agent. So this is, for example, an area called AI planning, which is a very hot area these days. Internationally, also path and motion planning, where the behavior is basically navigating spaces, right? And the area of program synthesis, which is basically coming up with programs automatically from a model. And in the model, we will express all the actions the agent or the system can do. So these approaches, of course, they are not orthogonal, and the group works on all of three, right, internationally. And in many cases, in most cases, they combine the different approaches. Now you say, where is this important? In many, many places, right? In robotics and human collaboration, we have to make decisions on what actions to do. In optimization and planning, to plan different course of action. For example, in the mining industry, right, how to go around with the trucks, in the logistics, how to deliver the packages. Or in autonomous decision systems, like robots in aerospace. So, for example, manufacturing, advanced manufacturing, you have many robots, many devices that can operate in the plant. You want to combine them intelligently, and each of them have to do different actions. They also have to talk among them and coordinate. Video games is another area that the group does. Julie works on generating narratives, right? So what are the actions of the characters that are non-players, right? So the non-character players, they have to look smart, right? And sometimes you can program them, but sometimes you want to learn from experience or get it from a model. Of course, as I said, NASA and many aerospace domains include this kind of decision on plans that extends over time, right? And this is the Mars rover. Another area that we're working a lot, and we have many staff working, is emergency management. How do we evacuate a group or an area when there is flooding or fires, right? And we are working with different entities in the government here in Victoria, right, to deal with this. Another one is tactics, and there's staff working with the defense on developing tactics that involve both computer software and robots, and also humans. Okay? And of course, human collaboration, right? Smart houses and other areas. Anyway, so here are the staff. I invite you to check the AI Lab link here, where you will see the profile of each of these people. Some of them, like Fabio, for example, they overlap with areas as well. So thank you very much. Hi, all over to you.
Thank you, Sebastian. So next, let's welcome our past graduate. First is Veronika Stephanie to share her stories. The honors program. Welcome.
Yes. Thank you. Hi. Let me share my screen. Can you see my screen? Hello?
There is background noise. I don't know why.
Yeah. So can you see my screen?
Yes.
Yeah. So hi, my name is Veronika, and I'm here to share my journey before, during, and after my honors study. So a bit about myself. I'm currently a first-year PhD student in computer science under the supervision of Associate Professor Ibrahim Khalil and Data 61. And my current research interests are privacy and security, edge and cloud computing, AI and machine learning, and also blockchain. So before I started my honors, I was an undergraduate student in Venus University in 2016. So I started to go to RMIT as a double major student in 2019. And in the same year, I undertook a small project with Associate Professor Ibrahim Khalil. The project was about a research on the performance of distributed system using Raspberry Pis. In this project, I learned about how to distribute computing tasks to edge devices. And this was the time when I realized that I was interested in research. So, and in 2019, I got my bachelor degree in IT. And at the same time, I kept in touch with Associate Professor Ibrahim Khalil and did a small project with him over this summer. So having done this project with him had led me to pursue an honors degree. And my honors thesis topic is actually related to the summer project that I did with him. And my thesis was about preserving the user location privacy and machine learning based user location recommendation system. And with his guidance and advice, I got the chance to learn how to publish my first journal before I graduated in 2020. I believe in, from my understudy, it has helped me a lot to improve my time management skills, critical thinking, problem solving, and presentation skills. And also, in addition to that, after finishing my honors, I got the chance to do an internship with Zahir Data 61, which is one of the well-known government agencies. And also by doing research, by doing honors, I got the opportunity to get an ARCDP PhD scholarship in blockchain and privacy from my supervisor. So if you're interested in working with topics really related to like blockchain or privacy or machine learning, please do not hesitate to contact me or my supervisor, as we still have scholarships available. Thank you.
Thank you, Veronika. So let's welcome our next presenter, also another honors graduate, Ms. Aditya Kalapaaking, to present his story.
Yeah. Hello, everyone. Can you hear me?
Yes, yes.
And yeah, here is my. Can you see my screen?
Yes.
Okay. So yeah, my name is Aditya Pribadi Kalapaaking. I'm a PhD student now in computer science. So yeah, I also first year in the computer science PhD student. So I work under the distributed system and network security. My supervisor is same with Veronika, Associate Professor Ibrahim Khalil. And my research interest is in cybersecurity, blockchain, and PPML, or privacy preservation in machine learning. So in bachelor, I did a capstone project too with Mr. Ibrahim. I create a Raspberry Pi cluster. Here's the picture. Here is like the prototype. We create a prototype on my bachelor during my capstone. And I get my bachelor in IT in 2019. And I also take honors after I graduate from my bachelor. I also take from my honors with Mr. Ibrahim Khalil. And my honors thesis is talking about blockchain-based access control with search result verifiability. I graduated in 2020. And during an honors, you will learn how to do a proper research. We done this in the research method class. I done this with Mr. Xiaodong Li. He's very good in the research. So I learned a lot how to do a proper research. And from my supervisor, I think like critical problem. So basically in honors, we need to think a problem that haven't solved. And then we also need to think how to solve the problem itself. And yeah, we need to learn a proper experiment during our research and learn how to write a good paper or journal. So once you've done your honors, you can create a publication like in the IEEE or in the Elsevier. So pathway after graduate. So after you graduate from your honors, you can apply for PhD degree. Also, you can get a scholarship too. Like me and Veronika, we get a scholarship under the IRP. And RMIT also support for the tuition fee. Also for the internship or work and or research. So after you get your honors, you can work on the research institution or research department. Also get an internship and CSIRO and Data 61 during my summer intern. Also, if you want to apply a job after you graduate from your honors, it's gonna be a plus point for your employer. When he see your resumes, it will be a plus point because you've done a research. Also, this is a possible project from our team, which is we are doing now on the PhD. So basically, we are securing IoT using blockchain and encrypted learning. And this project is funded with ARP and can be extended to the PhD too later. And yeah, here's my supervisor contact. You can contact us or me itself to talk about the project, or if you want to ask about the experience. Thank you.
Thank you very much, Aditya.
Yeah.
Okay, so all right. So because the time runs out, so we don't have the time for the online Q&A, but we do offer offline Q&A. So if you have any questions regarding the program or the course, you're welcome to post the questions in the discussion board, in the chat room, or just directly send me by email. Okay, so yeah, that's pretty much the content of the information session today. Thank you very much for your participation. Thanks.
Thanks, Sai.
Thank you, Matt.
Thank you.
Thank you.
Bye.
Hi.
Thank
See you
Bye.
guys. Bye.
Thanks. Hi. Bye.
Bye.